Over half a century ago during the Apollo missions, after landing on the surface, astronauts would usually stay for less than 48 hours. After that short time, they were required to get back on the lander and begin their journey back to Earth. The moon lacked the proper infrastructure to support humans for extended stays, which in turn held back the possibilities and exploration that could be completed. For the upcoming Artemis missions, NASA wants to create a substantial lunar base, capable of keeping astronauts safe, healthy, and prepared for work on the surface. While there are still a few unknowns, we have a good idea for the future base location, general structures and plans, and how they will deal with temperature, radiation, etc. While it won't be easy, if done right, this lunar outpost could be the start of something incredible, and help facilitate many future missions on and beyond the moon. Here I'll go more in depth into NASA's moon base plan, the purpose it plays, what to expect in the coming years, and more. Picking the right location is one of the most important decisions of this future base. That's exactly why NASA has spent so much time looking at different options and weighing the pros and cons. By now, one thing is for sure confirmed: the future base will be located at the moon's south pole. This area features extreme light, extreme darkness, and frozen water that could fuel the agency's lunar base. More specifically, the site must bask in near continuous sunlight to power the base and moderate extreme temperature swings, and it must offer easy access to areas of complete darkness that hold water ice. While the South Pole region has many well-illuminated areas, some parts see more or less light than others. Scientists have found that at some higher elevations, such as on crater rims, astronauts would see longer periods of light. But the bottoms of some deep craters are shrouded in near constant darkness, since sunlight at the South Pole strikes at such a low angle it only brushes their rims. Initial plans include landing the Starship lunar lander on a relatively flat part of a well-lit crater rim or a ridge. You want it to land on the flattest area possible, since you don't want the landing vehicle to tip over, said a NASA Goddard planetary scientist. As far as where exactly, the landing area ideally should be separated from other base camp features, such as the habitat or solar panels, by at least half a mile or 1 kilometer. It also should be situated at a different elevation to prevent descending spacecraft from spraying high-speed debris at equipment or areas of scientific interest. Some scientists have estimated that as a spacecraft thrusts its engines for a soft landing, it could potentially spray nearly 1 million pounds or hundreds of thousands of kilograms of surface particles, water, and other gases across the surface. This could easily damage equipment and cover solar panels. You want to take advantage of the landforms, such as hills, that can act as barriers to minimize the impact of contamination. So, we're looking at distances, elevations, and slopes in our planning, says Ruthin Lewis, a leader on NASA's South Pole Site Analysis and Planning team. In addition, on the moon, it's critical to keep the area around the landing site and base camp as pristine as possible for scientists. For instance, among the many interesting features of the South Pole region is its location right between the Earth-facing side of the moon, or the near side, and the side we'd never see from Earth, known as the far side. These two hemispheres are geologically very different, with the far side more heavily cratered and its crust thicker than on the near side. The Artemis base camp has to be in the Earth-facing side to make it easier for engineers to use radio waves to communicate with astronauts working on the moon. But scientists expect that over billions of years of meteorite impacts on the moon's surface, rocks and dust from each hemisphere were kicked up and strewn about the other, so it's possible that astronauts could collect samples of the far side from their base camp on the near side. In August of last year, NASA identified 13 candidate landing regions near the lunar South Pole. Not too long from now, we can expect an exact location of these future missions. In addition to the location, NASA has been working on building plans for future habitation and general infrastructure. One option that the agency is very serious about is 3D printing structures. Late last year, NASA awarded ICON, located in Austin, a contract to develop construction technologies that could help build infrastructure such as landing pads, habitats, and roads on the lunar surface. In order to explore other worlds, we need to innovate new technologies adapted to those environments and our exploration needs, said Nikki Werkheiser, Director of Technology Maturation and NASA Space Technology Mission Directorate. Pushing this development forward with our commercial partners will create the capabilities we need for future missions. ICON 3D printed a 1,700 square foot simulated Martian habitat called Mars Dune Alpha that will be used during NASA's crew health and performance analog missions starting in 2023. The company also competed in NASA's 3D printed Habitat Challenge. The goal is to use the materials already on the surface of the moon to create large and consistent buildings with or without humans present. In the case that NASA does use 3D printers for habitats, more work would likely be required to make them safe for humans. For example, radiation is a big concern for future humans on the surface. In this case, the more mass between the crew and radiation, the more likely the dangerous particles will deposit their energy before reaching the crew. On the moon, astronauts could pile lunar soil or regolith over their shelters, taking advantage of their environment's natural shielding materials. But where spacecraft design is concerned, relying on sheer bulk for protection soon grows expensive, since more mass requires more fuel to launch. Another important piece of infrastructure that the agency is considering is a lunar South Pole oxygen pipeline. The sustainability of the Artemis program and its goal of developing a permanent human presence on the moon is dependent on the ability to utilize in-situ resources to reduce the cost and risk of lunar operations. NASA and the US government have invested significant funding in developing the ability to extract oxygen from lunar regolith and water from lunar ice. The oxygen will be used for 1. Human habitats, rovers, other life support systems with a constant supply of high-purity oxygen for human consumption, and 2. Oxidizer for launch vehicles departing the moon. These oxygen extraction technologies are planned to be demonstrated at a large scale on the moon as early as 2024 and provide direct support to Artemis astronauts as early as 2026. The starting concept is for a 5-kilometer pipeline to transport oxygen gas from an oxygen production source, for example, the molten regolith electrolysis extraction site or any other source, to an oxygen storage plant near a lunar base. The pipeline would be composed of in-situ manufactured pipe segments that are passivated and welded or fitted together to span a 5-kilometer distance. Based on preliminary analysis, they are assuming the in-situ pipe is built in modular segments from aluminum, as is prevalent at the South Pole, is extractable in high purity, can be directly extruded into the pipe shape, and can be oxidized to passivate. The modular design is intended to be adaptable, repairable, and evolvable because of the resource extraction and manufacturing techniques, resulting in a long life for the pipeline and lower cost and risk than other approaches. When on the moon, the lunar ice is expected to provide a lifeline for astronauts. Developing a blueprint for exploring the solar system means learning how to use resources that are available to us while also preserving their scientific integrity, said Jacob Bleacher, Chief Exploration Scientist for NASA. Lunar water ice is valuable from a scientific perspective and also as a resource, because from it we can extract oxygen and hydrogen for life support systems and fuel. In the darkest and coldest parts of its polar regions, a team of scientists has directly observed definitive evidence of water ice on the moon's surface. These ice deposits are patchily distributed and could possibly be ancient. At the southern pole, most of the ice is concentrated at lunar craters, while the northern pole's ice is more widely but sparsely spread. The overall goal is to use as many moon resources as possible. Despite the innovation within the space industry, it still costs an immense amount of money to get even just a single kilogram of anything to the moon. In the future, as more missions launch at a faster pace, the agency is expected to begin building a physical base with everything needed to stay for weeks, if not months at a time. NASA has a lot to consider when planning to create a lunar outpost. Between the landing site, radiation, habitation, oxygen, and water, the list just keeps going. This being said, we are not far away from Artemis 3 and the first humans to land on the moon in over half a century. An important first step in turning the desolate moon into a science laboratory and base. We will have to wait and see how it progresses and the impact it has on the space industry. Thank you very much for watching.